Okay, today we're going to talk about equivalent fractions, and we're going to see some examples of equivalent fractions, so let's get into it, man. So if I have the fraction 1 over 4 and the fraction 2 over 8, they're saying that it's equivalent. And the reason why is because if you look at these circles, if I were to draw 4 pieces for this circle and color in 1, that would be 1 out of 4 colored in. If I were to do this one, put 8 pieces, and then color in 2, that would be I have 2 out of 8 pieces colored in. That would mean I have the same amount of the circle colored in. It's the same amount of the circle colored in, so they're equivalent. They're equal to each other. Another way you can do this is by dividing the denominator, which is the bottom number, by the numerator, which is the top number. If I were to divide 4 by 1, that just equals 4. If I divide 8 by 2, oh, I don't know why I'm using this one. I should be using the other one. That's just 4. So they're equal to each other. That's another way you can figure out whether fractions are equal to each other. So let's do that over here. If I were to have the fraction 3 over 12, 12, and then the fraction 4 over 16, they're saying they're equivalent, but how do we know? Well, again, we can divide it. 12 divided by 12 divided by 3 is equal to 4. And 16 divided by 4 is equal to 4. So these fractions are equivalent. Okay? Because they make up the same part. It takes the same amount of them to make up a whole. And if I were to have, let's say, the fraction 7 over 21, 7 out of 21, and I would say that would be equal to 2 out of 6. Well, how can I show this? Well, again, we got to see if they make up the same amount of the whole. Okay, and if I do that, we can divide 21 by 7. And we get 3. That's equal to 3. And then 6 divided by 2 is also equal to 3. So they're equivalent fractions. Now, the reason this works, again, is because if I had 6 balls, 1, 2, 3, 4, 5, 6, and I were to circle 2, it would take 2 more groups of 2. It would take 3 groups of 2 to circle the whole thing to make 1 group of it. If I were to have 21 balls, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And then I were to take 7, 1, 2, 3, 4, 5, 6, 7, circle 7, I would need to circle 7 3 more times to make up 1 whole group. So they make up the same amount of their own group. Just like with the circles, they make up the same amount. They represent the same amount of the circle. And that's why we're able to divide it like this and figure out whether they're equivalent fractions by dividing them. By dividing the denominator by the numerator. And if they're both equal to the same number, then equivalent fractions. Another example of an equivalent fraction would be, let's think, 10 over 30 and 1 over 3. 30 divided by, 30 divided by 10 is equal to 3, and 3 divided by 1 is equal to 3. So they're equivalent fractions because they make up the same amount of the circle. They shade in the same amount of the circle. So sounds good.